We'll be taking a look at example number 2, and I would like you to press pause shortly after this, but I would like you to put together or draw the lines, segments A, B, C, D, and put it on this Cartesian graph, and then line segment EF and GH, and put it on this graph. So press pause, you do that, and then when you return, we can get started. All right, so I have graphed. I believe I've done a good job here. Very tricky. So first off, on first blush, I believe it looks like the slope of AB and CD are going to be the same. Example number 2, the coordinates of the endpoints of pairs of line segments are given. Graph each pair of line segments and determine their slopes. Which line segments are parallel? So for whatever reason, I'm just going to say the slope of AB. I'm going to calculate the slope of AB, and then I'm going to calculate the slope of CD. And I'm going to draw my little triangles, and the slope of AB, I know that my change of y, now remember that slope is really going to be your change of y over the change of x. I'm going to draw my triangle here for AB. The y coordinate goes from -1 to 5, so that is an increase of 6 in y, so it's positive 6. For the x coordinate, I go from -2 to 1. Sorry, this was 6, so I go from -2 to 1, so it looks like a change of 3. So my slope of AB is 2, 6 over 3. Now over here, on line segment CD, I'm going to make my little triangle again. And what I notice is that the vertical change goes from -1 to 3, so that's a change of 4. And it goes from 2 to 4, that's a change of 2. So the slope of CD is the change of y is 4 over the change of x is 2. So the slope of CD is 4 over 2, which is 2. So what can I conclude? Therefore, AB is parallel to CD. So those two vertical lines, when I put them like this, it implies that they are parallel. They're two parallel lines. All right. Now, I'm just going to double check here because when I look at this, are they, well, number one, I need to find out the slope. But number two, they are not parallel and indeed, they almost appear like they cross. And by the way, it's hard to tell because I have one point here, and I believe it was H. H fell off the graph, so it's very difficult to determine. So what I'm going to use is my slope is my YE minus my YF. So this will be my slope of my line segment EF, divided by XE minus XF. And I'm just going to do this. So YE is 4 minus YF is 2, divided by, sorry, YF was -2, divided by XE is -1, subtract XF is 7. And what I get here is that the slope of EF is going to be equal to 4 minus -2 is 6, divided by -1 minus 7, that is -8. So if I reduce that, what I will get is -3 over 4. So this is slope of EF. Now the reason why I'm taking a more algebraic approach and using a formula is simply because I'm uncertain. And by the way, which way should you know? You should know all the ways. That's how you get good at math, is that No matter what circumstance, you can imagine a process to get out of problems. Here, I'm just going to do the slope of GH now. The slope of GH is y of h minus y of g divided by the x of h minus the x of g. So when I look at GH, I know that it should be negative because we're going downhill, so that the slope of GH, so the y of the h coordinate is 0 minus y of g is 4 divided by the x of h is 9 minus x of g is 3. So what I do get is I get the slope of g of h is negative 4 over 6, or negative 2 over 3. So the slope of GH is equal to negative 2 over 3. So what we get is that they have different slopes. Are these two line segments parallel? So what I can say is that EF is not parallel to GH. And I'm in brackets, I'm going to put different slopes.